Swayam Prabha. Digital India. Educated India.
Welcome to Module D, Lecture 10. In this lecture, we shall discuss about analysis of single, intermediate and two-lane roads as per Indo-Highway Capacity Manual 2017. Till lecture 9, we discussed mostly based on Highway Capacity Manual 2016, US Highway Capacity Manual, and specifically in lecture 9 we discussed about planning level analysis for urban road segments, calculation of running time, then proportion of vehicles arriving during green, control delay, stop rate and also travel time, speed, spatial stop rate and finally calculation of LOS. And we took a simple example problem to explain you how you can calculate carry out planning level analysis to understand the level of service. Now, today we are actually starting a new part in the sense that we will discuss about Indo-Highway Capacity Manual. Now, as you know, the manuals like US Highway Capacity Manual 2016, we have referred to this manual extensively in our several lectures in this module. Also similarly, there is a Chinese manual, Indonesian Highway Capacity Manual. All these were developed based on traffic condition present in respective countries, and it need not be just one country, but also sometimes like US Highway Capacity Manual, multiple countries, several countries will have similar kind of traffic state and where HCM can be applied. Highway Capacity Manual 2016 can be applicable. But traffic on Indian roads is composed of slow and fast moving vehicles, highly heterogeneous, so many varieties drive and with substantial differences in their both static and dynamic characteristics, including the size, engine power, everything. There is quite a lot variation. And also wide range of motorized and non-motorized traffic sometimes use the same road space, resulting in highly heterogeneous traffic environment. So, therefore, many of the provisions methodology wise may be quite advanced, quite detailed, but many of the assumptions may not be really valid for Indian heterogeneous traffic condition. Not only the traffic environment, but the roadway control environment, the averting land use, the kind of side friction what we get. So, the real behavior of the traffic, even speed flow relationship also might be very different for uninterrupted flow facilities. So, there was a need and an attempt was made to develop a Indo-Highway Capacity Manual in 2000, which came out in 2017, and you may consider it as this is the first version, version 1 of this manual. So, obviously, lot of things have been done, but lot of things are also yet to be done. So, I want to give you a little bit quick understanding of some of the features of this Indo-HCM in today's lecture and the next lecture. So, lecture 10 and lecture 11 will be primarily on Indo-HCM. In Indo-HCM or in as per Indian conditions, we have both urban and rural, as we have done in the case of Highway Capacity Manual 2016. Rural we specifically calling here as inter-urban highways, and they include sometimes single lane road, sometimes intermediate lane road, two lane road, also multi-lane highways and even expressway. These are not urban expressway, but interurban connectivity with access controlled road. Multi-lane highways are not access controlled, and that is really a big challenge in our Indian context. Now, out of all these roads, different categories, different accessibility mobility functions, single lane, intermediate and two lane roads are basically undivided and facilitating two-way traffic movements. Multi-lane highways and expressways are divided carriageways. So, upstream downstream moving in different, using different, distinctly different and physically segregated carriageways with two or more lanes in each direction. Now, obviously, the traffic operations on undivided and divided highways are largely different, and therefore, the capacity and LOS analysis are also presented separately for divided multi-lane highways and undivided roads in the Indo-Highway Capacity Manual. We will not have opportunities to go for urban roads because of the time limitation, but we shall focus how the capacity and LOS, at least the key aspects, in today's lecture and next lecture, lecture 11. Today we shall focus on undivided roads. So, now capacity and LOS estimation for single, intermediate and two lane roads. Interurban undivided roadways have two-way movement which influence the capacity of the road. So, basic concept, basic understanding is always same irrespective of which manual we are referring to. I have told you that the passing opportunity greatly influenced by the opposing flow level, flow in the other direction. Higher the flow, less will be the opportunity, and higher the flow in the direction of the movement, there will be higher demand also for doing the passing. So, the passing opportunity is a major consideration here also. Two lane carriageways as per Indian provision generally have the carriageway width of 7 meter, 3.5 meter per lane, assuming that there is no curve. Most of the rural sections you do not expect curve. So, 7 meter. Intermediate carriageway width of 5.5 meter. Intermediate carriageway is not very common, but in Indian condition it is there because single lane you have 3.75 meter carriageway. Sometimes single lane the passing opportunities is extremely difficult, both vehicles have to go and use part of the shoulder, part of the carriageway to do it, to do the maneuver, passing or even crossing both. So, an intermediate carriageway is something in between, a compromise two lane in a sense, with carriageway width of 5.5 meter, often it could range also up to 6 meter or so. And this at least in a limited way provide passing and crossing opportunity. If two cars want to cross or one car wants to pass another car, they will be able to manage probably within 5.5 meter. But if two trucks or heavy vehicles are trying to pass or cross each other, then they have to use part of the shoulder and part of the carriageway. Now, like the highway capacity manual, here also the base conditions are defined, and in addition to this prescribed carriageway width, as I have just said, for single lane, intermediate lane and two lane undivided roads, they also have additional assumptions like the shoulder must be present on both sides, at least minimum of 1 meter shoulder. Then section should be straight and level. So, if there are gradients, then gradient effect has to be accounted for separately. No influence by interruptions such as intersections, then steep gradients and curvature. So, if there is that is again level ground. So, if it is no effect of steep gradient or curvature as well as any other adjoining roads. No physical barrier on at least 500 meter section means physical barrier in the sense the most common physical barrier is the speed breakers, speed breaker, rumble strips, speed humps. So, on Indian roads often we find that because the abating length is something very different. The intended and actual use of road is very different. A road may intended use may be to serve mobility, but actual use may be very much higher performance on higher requirements to serve really accessibility. So, the actual and intended, so the speed limit and safety speed, it is all a more complex issue and complex problem. So, it is assumed that there is no physical barrier for at least 500 meter section. Section should be free from any other roadside friction activities. That is again an important consideration. Section should be free from any work activity for at least 1 kilometer on either side, nothing like some part of the road is blocked and work is in progress. So, that will again disturb the traffic stream, and also no incident or crashes at the time of observation for at least 1 kilometer on either side. So, that all these are assumptions to define the base condition. So, base condition is almost, as you already know it, it is almost like nearly idealized situation. So, and then we apply again as usual several correction factors, may not be exactly the same way as it is done in the Highway Capacity Manual 2016, US Highways Capacity Manual. Here the considerations are much simpler, and I will show you some of those. So, here is basically the framework how you can decide capacity and level of service. Very quick look, selection of study location. So, it may be either 2-lane road or intermediate lane road or a single lane road. Then you go for the data collection. Two types of data you collect, one is basically the traffic related data, the other is geometry related data. Traffic data mostly as per Highway Capacity Manual, Indo-Highway Capacity Manual or INDO-HCM, we are saying that use videography as far as possible for collecting the traffic data. So, traffic volume, composition, speed, free flow for speed of cars, right, standard cars what we take. So, all these are can be collected using videography data, and the geometric data may include carriageway and shoulder width, terrain type, pavement condition, horizontal curve or curvature, vertical gradient, all such kind of inputs. Then the estimation of PCU, as you know the Indian traffic condition is highly heterogeneous. So, as most of the cases the Highway Capacity Manual we consider only heavy vehicle or sometimes even just another category recreational vehicles, right. But here the mix, the range of mix is quite vast, right. So, we have to how to use the PCU values is also a challenge, and as you know the passenger car, passenger car equivalency and passenger car unit, they mean the same thing, we call it passenger car unit, but while in most other countries, many other countries probably they call it passenger car equivalency. So, PCE or PCU, they are again dynamic, not static. So, use of different values depending on composition, presence of other vehicles, different other factors they influence the PCU value. So, the dynamic PCU value range, it suggests the range. Observed composition is so much percentage for a vehicle, and the PCU also may vary from this range to that range. So, accordingly for every vehicle type it is given. A new concept which is introduced in the Highway Capacity Manual is the stream equivalency factor. Instead of using individual vehicle type, dynamic PCU and getting the equivalent PCU, directly the stream equivalency factor can be multiplied with by the number of vehicle to get the flow in PCU. This one value directly can be multiplied based on the composition of the traffic stream and other things. Again the development formulas are developed. Then capacity under base condition is calculated, taking the operating speed at 85 percentile speed and for passenger cars, and then several adjustments are done on that, because the capacity is under base condition. So, adjustment may include carriageway weight, pavement shoulder, the road geometry, and then finally the number of followers also may be counted for calibration purpose, for understanding purpose, and then finally the level of service is decided. And here two things I have indicated in blue font. They show that is what is the measure which is used to define the level of service. So, for example, for intermediate and two-lane road, its number of followers as percent capacity. What is the capacity and what is the number of followers as percent capacity? So, NFPC, that is used as a measure for defining the level of service. So, we calculate this end of the day when we are using this framework, and for single lane road, it is the volume to capacity ratio. So, in that case the V by C is calculated. So, capacity we have calculated, we know the volume from the videographic data, right. So, for the given volume, what is the V by C ratio? Now, with this background, let us see some of the key concept. As I say, the stream equivalency factor is a new concept that is introduced to Indo highway capacity manual. As I said, the PCU value of a vehicle type is found to be sensitive to traffic and roadway condition. So, a single PCU value cannot be used for all types of traffic condition. So, what is done here in this manual, it presents that in multiple locations in different parts of the country, so many roads are taken, and the observed range of composition for each vehicle type. What is the range? Because in different section, different percentage, different composition was observed. So, it presents a range and then presents a range of PCU value. So, depending on the context, the manual also can be used to pick up a particular value of PCU, which is actually suitable for the context. It is dynamic PCU. And what is always found, as I told, that a small change in the traffic volume or composition may change PCU factors substantially, especially for large size vehicles, which have got bigger impact, which get actually influenced by this parameter. So, therefore, the stream equivalency factor, this concept is introduced, that let us not try to use dynamic PCU values based on the composition, based on the condition, pick up a value, observe composition and so on. We can have a single value which can be just simply multiplied by the number of vehicles to get the flow in PCU per hour. So, ACF, stream equivalency factor, is defined as the ratio of flow in PCU per hour to the flow in vehicle per hour. So, what is the flow in PCU per hour divided by what is the flow in vehicle per hour. So, you use one factor which duly considers the composition, the volume effect. As I said here, the traffic volume or composition may change PCU. So, this volume effect is considered, composition effect is considered, and can help you to directly translate total traffic volume in vehicle per hour into PCU per hour, equivalent stream of homogeneous traffic. Now, what is also found, that the flow in PCU per hour when you estimate, and flow is also a factor. As you can see that as the flow increases, the PCU also increases, right. The flow in PCU increases, and these are, there is some kind of correlation, right, and this is shown for flow in PCU vehicle per hour and the corresponding flow in PCU. Here also the flow in vehicle per hour and flow in PCU. This is for two lane and intermediate lane road, and this is for single lane road. So, based on that, all such kind of observations and understanding, as AC represents the overall equivalency factor of the entire traffic stream. So, stream equivalency depends on volume and composition. As I have said earlier also, a small change in volume and composition may change PCU factor. So, here also the AC is made sensitive to composition and traffic volume. So, based on extensive data collection for each category of road, different range of traffic composition, overall traffic volume. So, extensive works are done to develop such kind of equation which you can use. So, you can see that this is for single lane road, this is for intermediate and two lane road, how one can use the stream equivalency values. So, it is 1 plus, it is taking percentage of big cars. Big cars means two types of car. What we are taking as standard car is up to engine capacity of 1400 cc, and big cars means which is bigger than or capacity more than 1400 cc. So, percentage of big car, percentage of two wheeler, percentage of auto rickshaws is the three wheeler, typically that is what is called. Then proportion of light commercial vehicle, proportion of 2 or 3 axle trucks, proportion of track trailer, proportion of multi axle trucks, and also as I said the PCU or PCE or equivalency, stream equivalency also depends on total flow. So, that total flow is also used as a variable here, you can see. And very logically the two wheeler percentage, the coefficient comes with negative sign, and the number of vehicles where this is used, this again comes very logically with a negative sign. They all are generally positive, right, because these are bigger vehicles, bigger than what is considered as standard car. So, these stream equivalency equations, as I have shown here in this module as 4.33 and 4.34, can be used directly to get the stream equivalency for a given composition and number of vehicles. So, then the base capacity estimation, this was again done, extensive field data collections was done to try what or how the relationships come up. Here you can see the total capacity, it is found to have some kind of relationship with the operating speed. So, the operating speed of cars, this is operating speed is taken as 85th percentile of free flow speed of standard cars in field. So, as operating speed increases, so the capacity also is found to increase. So, the one equation is developed for two lane roads, the base capacity under ideal condition is taken as 394 plus 34 into VOS, where VOS is the operating speed of road. That is operating speed means it is the 85th percentile free flow speed of standard cars in the field. So, this equation can be used. Once you know the speed, these are all calibrated at the back end. The Greenshield's equation, the speed flow density relationship is also considered to be valid. So, lot of other assumptions, other works, extensive field work, observations are all made to suggest this. Similarly, the intermediate lane road and single lane road, two other equations very similar to this equation what is shown here for two lane roads, a very similar equation is suggested. And here also the VOS is basically the operating speed as taken as 85th percentile of the free flow speed of standard car. And here as I have shown it for two lane road, it is also shown for intermediate lane road that speed has got an impact on capacity. So, that operating speed has got an impact on capacity. So, that is actually captured here. Then as I said that under base conditions things are different. So, now the prevailing condition will expected to be very different from the base condition. So, lot of corrections are to be applied. So, here capacity of road is found to get affected by various factors, say for example, carriageway width, shoulder width, and condition. Then the directional split, it is undivided road. So, the directional split is again very important. The road geometry, particularly the curvature and gradient, and also the pavement condition, which we can express in terms of the roughness, IRI values, International Roughness Index. First, coming to the carriageway width, such kind of correction factors are suggested by the manual, and again I am saying these are based on extensive research, field observations, data collection on number of roads under the same category with different carriageway width, and then trying to capture the relationship and then trying to suggest what based on that understanding that what kind of correction factors may be appropriate. So, you can see for 2-lane, for intermediate lane, single lane, 2-lane the carriageway supposed to be 7 meter ideally. So, it could be less than that, it could be more than that, then what multiplier we can use. Intermediate lane road supposed to be 5.5 meter, cannot be lesser because it is intermediate. So, we do not expect it to be even lesser than 5.5. So, it could be sometimes higher and go up to 6 meter. So, the factors are calculated, given single lane road supposed to be 3.75 meter, then it is 1, if it is lesser then less than 1 multiplier, if it is more than 1 higher than 1 multiplier value is used as the factor. So, these are corrections related to carriageway width. Similar correction is applied based on the pavement shoulder. You can see that pavement shoulder width in meter, and then what is the correction factor. Then the directional split 50-50 is assumed, right, and then capacity decreases as the directional split move away from even split of 50-50. So, 50-50 case it is 1, and then as it is becoming different, the different values are used. Then the road geometry influence a lot, and where you expect such things to happen, the curvature and gradient, right. Curvature and gradient, where we expect them to impact, it is basically in hilly areas, difficult terrain condition. And what is interestingly found, that in hill roads operating speed is found to get influenced by road geometry such as gradient and curvature. Capacity definitely getting impacted, but the operating speed itself is getting impacted by the road geometry, particularly say gradient and curvature. And as gradient or curvature is increasing, the operating speed is actually decreasing, right. So, what is done in the absence of the observation in the full range of flows, starting from free flow congestion to capacity level or congested regime, the entire range of observation. So, what again was considered, take the free flow speed of cars, estimate it considering the impact of the not the free flow speed, but the operating speed of car, duly considering the effect of the gradient and curvature. What is the, and this operating speed is what? It is the 85th percentile speed, as I have told earlier, considering standard car or small car. So, operating speed is taken as the 85th percentile speed of free flow speed of standard car in field. So, observe it. So, take the effect of gradient and curvature on operating speed, and then relate, as we have done other case, relate this operating speed to the capacity, as we have done in earlier case also, but this is specifically for 2-lane hill roads. So, that is what was done. Operating speed of cars you can either observe in the field or estimate using this equation as given here. You can see here operating speed reduces once the gradient is steeper, gradient is more, or the curvature, that means degrees deviation per kilometer, average change in degree per kilometer, once that changes. Then the relationship is established between capacity and operating speed of standard car, as I said. So, the capacity is expressed like this, very similar to what I have shown earlier for this 2-lane road then you have intermediate lane road and single lane road, but this is again specifically for 2-lane hill roads, duly considering the effect of curvature and gradient on speed and therefore, on the capacity. Now, similarly, the riding quality, the effect of IRI, international road roughness is taken actually, and then operating speed effect is considered here. Then effect of roughness IRI on capacity was also directly captured based on the available data, and relationships were developed. So, with paved shoulder, without paved shoulder, then this is for 2-lane road, and then for intermediate and single lane road, how the things change, that was given. Coming to the LOS estimation, in INDOHCM, LOS for intermediate and 2-lane road is defined based on the number of followers as percent of capacity. It was reviewed several measures which are used in different manuals all over the world for undivided facility in similar situation. These were all reviewed. Then in Indian conditions, what are the challenges, what are the problems, what could work better, if we want to apply, then what kind of practical difficulties we may face, all such kind of things were considered, and finally, these NFPC, number of followers as percentage of capacity, this was used to define the LOS for intermediate and 2-lane road. So, this was taken as the service measure. For single lane road, V by C, volume to capacity ratio, was prescribed. So, a vehicle is considered to be the following state, little bit about the NFPC. A vehicle is considered to be in the following step if it moves with a gap value equal or less than the critical gap. So, based on the critical gap, it was said, and critical gap value obviously decreases with an increase in the traffic volume in roads, vehicle move more closely. So, there is a relation which was again developed and given in this manual, so which you can use as I have shown here as equation 4.46. So, if we know the traffic volume, we can calculate the NF value, number of followers. Okay. So, number of followers in PCU per hour can be expressed as a function of 2-way total traffic volume in PCU per hour, and obviously, as the traffic volume increases, the number of followers also will increase. So, this relationship was developed and one can use it, and then using different ranges of NFPC, once you know the NF, number of followers, we can also, considering the capacity, we can calculate number of followers as percentage of capacity. We can just translate NF into to express it in terms of NFPC. So, we can do that. So, different ranges of NFPC for different LOS are given in the table. I am just going to show it here. And what I want to say, the corresponding ranges of V by C ratio are also given. You can see here it is for intermediate and 2-lane road, where NFPC is the basically service measure to define the level of service. So, the threshold values are all given, but also the corresponding V by C ratios are also given. Does it mean that directly we are saying that take the V by C ratio? Not directly in that sense, but what was done, the corresponding ranges of V by C ratio are also derived, because we had huge data that was available. So, the LOS was the NFPC values were also calculated, known, and also the V by C was known. So, then using the cluster analysis, this corresponding V by C ratio thresholds were also worked out. So, that is what I say, the corresponding range of V by C ratio derived through cluster analysis are also presented, and what we did, because this is for easy understanding of analyst. Whatever you do, although internally we are actually considering NFPC, but giving these V by C ratios are very handy, because practitioners can easily get, you get the volume, what is the V by C ratio, you apply it, very simple. very simple rather than trying to calculate the NFPC. So, both are given. NFPC calculation is also not so difficult, one can easily do it. You have a formula directly which you can use, but corresponding V by C ratios were also given. So, that we generally get a feel that how the volume, as the volume is increasing, how the NFPC and overall the LOS thresholds are happening. Similarly, as I said, for single lane road it is only the V by C ratio. So, the threshold value for A, B, C, D, E, F, as you know, F is always greater than 1. Here also anything V by C greater than 1 is safe. And here the LOSB thresholds are given, because these are in rural or interurban facility. So, the PCU here is expressed as PCU, the demand is expressed, design service volume, the demand is expressed in PCU per day, but that internally this understanding is there, that capacity per hour, and then the what is the percentage of daily traffic to peak hour traffic. So, all those things are there internally to explain it. Now, just take a small example, determine LOS service for a 2-lane road, given this data. So, 2A volume is given, base capacity in this case is given, we could calculate based on the operating speed, directional split ideal, carriageway width ideal, earthen shoulder 1.5 meter on both sides. So, traffic compositions are also given. So, what we could do, solution I have just shown it here, very simple, directly you calculate the stream equivalency. So, use that equation what was given earlier for 2-lane road, and then you can get the flow in PCU, taking the flow in vehicle per hour, multiplying it by the stream equivalency, what is 1.488 in this case. So, the number of followers, then you can simply calculate using this equation. Q is known, so NF is known, NF is known, and the capacity is also given. So, and everything is ideal, right, no further adjustment is necessary. So, number of followers as percentage of NFPC can be calculated very easily. You calculate that and then refer back to this table what I have shown, corresponding NFPC value, and you can see the LOS is basically B. Alternatively, if you use the V by C also you can take, because the corresponding V by C is, as I say, based on cluster analysis, those were also given. So, V by C also refer to the same table, you will get LOSB. Going to another small example, determination of capacity using the operating speed of hilly terrain. This is the hilly terrain. So, 5 sections are given, each case the gradient and curvature is given. So, straightway we can calculate the operating speed using this equation, knowing the gradient, knowing the curvature, we can calculate the operating speed. So, that is what is calculated. Then once the operating speeds are known, the capacity can be calculated again using this equation. So, straightway you get the capacity for different section. So, what we discussed here, we introduced to you about the Indo-Highway Capacity Manual, which was published in 2017. Then the capacity and LOS estimation, what we use as measures of to define the LOS for single lane, intermediate lane and 2-lane roads, the concept of stream equivalency factor, base capacity estimation, various adjustment factors, shoulder width, carriageway width, gradient, curvature, and the LOS estimation, and took some small and very simple example problems to explain you the application. So, with this I close this lecture. Thank you so much.